Woohoo! It's a great day to be in geometry. I'm Miss Leg Battles, and I'm here today to talk to you about geometric probability. The probability that we're going to study is very much like the probability that you studied in the past. The probability that an event will occur is the number of favorable outcomes over the number of possible outcomes. Perhaps you remember the famous marbles in a jar problem. Recall that a probability can be expressed as a fraction, a decimal, or a percent. So in working problems, make sure that you answer in the form that is asked for. You can use geometric models to solve certain types of problems, and the ones we're going to talk about involve the probability of points on a segment or a region of a plane. All these represent outcomes. The geometric probability of an event is a ratio that involves geometric measures like length or area. When we're talking about probability and length, like the example shown, notice point S on segment AD is chosen at random. So the probability that S is on segment BC is just a ratio of the lengths. The ratio of the length of segment BC to the length of segment AD. Likewise, in the second model, when we're talking about probability and area, the probability that S is in region N is just the ratio of those areas. It's the area of region N over the area of region R. Now let's look at a couple of examples that I've chosen for you that are exactly like the ones I've asked you to work. Number 1 says point K on segment ST is chosen at random. What is the probability that K lies on segment QR? We just need to find the length of segment QR and the length of segment ST. So to find the length of segment QR, we just need to subtract 8 and 3. It doesn't matter which way because we're going to take the absolute value because we're finding the length of segment QR. That's this length right here. That is 1, 2, 3, 4, 5 units long. So that's what we're doing for that one. Now when we find the length of ST, the endpoints of S and T are 2 and 14. So that's going to be the absolute value of 14 minus 2, which of course is 12. So this is the probability that K lies on segment QR. It's 5 to 12. So this is when we want to write our probability as a fraction. Now, in the next example, it says the cycle of a traffic light at an intersection of two streets is 35 seconds green. So let's jot down what we know. It's green for 35 seconds. Then it's yellow for 5 seconds. We're hurrying through the intersection. And then it's red for 10 seconds. Okay, so that's red for 10 seconds. So the entire cycle is 50 seconds. So it's 50 seconds total. Now, what they're asking for is what's the probability that at any random time the light is red. Well, since it was red for 10 seconds, the favorable outcomes would be those 10 seconds, and then the total outcomes, that's the 50 seconds total. So we can see easily that this simplifies to 1/5. The probability that at any time when you arrive at that intersection, the light will be red is 1 in 5. I have 2 more examples for you, and I want you to notice that I've numbered them to correspond with the problems that I've asked you to work. Number 5 says a point in the figure is chosen at random. Find the probability that the point lies in the shaded region. And notice that the arc measure there is 84 degrees. So that shaded region is 84 out of the total possible 360 degrees. Now, if you want this in a simplified fraction, just put this in your calculator, and I have that modeled for us. Here's a picture of my screen on my calculator. Remember, it's alpha y equals, and that's our shortcut menu, the F1 menu, and then just choose enter because the very first one is the fraction. And when you put in 84 over 360, it'll simplify that to 7 over 30. Now that's if you want a fraction answer. If you just need a decimal approximation, you can either divide 8 by 360, or excuse me, 84 by 360, or 7 divided by 30. Either way, you're going to get a decimal that rounds to 0.233. And that's the way I believe it asks you to do it on the problem that I've asked you to work. The last problem says a point in the figure is chosen at random. Find the probability that the point lies in the shaded region. That means we're going to find the area of the red region, the shaded red region, and divide it by the area of the total figure. So to find the area of the red, we're going to need to find the area of the entire region and subtract out that center part. Remember, the area of a circle is pi r squared. Notice that since the diameter of the entire region is 10, its radius is 5, and that's what we need to find that area. Pi r squared, pi times 5 squared, minus the inner white circle. It has a diameter of 8, which means its radius is 4. So pi r squared is pi times 4 squared. So we have 25 pi minus 16 pi to represent the area of the red region. The entire region, of course, is what we started with when we were finding the area of the red region. It's simply pi r squared, pi times 5 squared is 25 pi. So when we simplify this, if we want it exact as a fraction, it's 9 over 25. When I divide that out on my calculator, I get exactly 0.36. I hope these examples will be helpful as you finish up your problems. It's been a great day to learn some geometry.